Okay, class. So for this empirical formula video, I thought I would spend a little bit more time, and I'm actually going to sort of show you the calculations that I would do, as I do this problem. So this is a very straightforward type empirical problem, empirical formula type problem. This is very common, and I think a lot of this, the aspects of this problem, we really need to sort of grab a hold of. So to get started, the information that we're given here: 27.13% carbon, 2.85% hydrogen, 15.82% nitrogen, and 54.20% oxygen by mass. So in this type of problem, like I said before, the sort of trick, or like the easiest way to solve this, is to assume 100 grams. So this little assumption is really key, I think, to solving a problem like this quickly and easily. The reason that we can assume a certain mass is because the percentages by mass, they're always going to be the same. No matter if I have 100 grams of material or 1,000 grams of material, these percentages, relative percentages, will always be the same. That sample will always have 27.13% carbon, no matter how much we have. And if I assume 100 grams, the convenient thing about that is that then I can say, well, in this sample, if I assume 100 grams, that means that I'll have 27.13 grams of carbon, 2.85 grams of hydrogen, 15.82 grams of nitrogen, and 54.20 grams of oxygen. So this is the whole sort of purpose. It's just the most convenient way for us to solve this problem. Now, if we're looking for an empirical formula, the empirical formula is really a ratio of how many carbon atoms do I have to how many hydrogens do I have to how many nitrogen atoms do I have. So it's a mole-to-mole type ratio, or an atom-to-atom type ratio. So I cannot compare these masses. These masses don't really correlate to the number of atoms that you have. So what I need to do for all of these is convert from grams into moles. So I'm going to do that by multiplying by 1 mole over 12.01 grams for carbon. So this 12.01, that comes from the periodic table. This is how I would convert from 27.13 grams of carbon into moles of carbon. So on my calculator, I would just type in 27.13 divided by 12.01, and I get 2.26. So I'm going to round that to 3 sig figs. Really, we could use 4 sig figs here, but I'm going to round that to 3 sig figs. 2.26 moles of carbon. I'm going to do the same thing for hydrogen, nitrogen, and oxygen. So for hydrogen, it's going to be 1 mole over 1.01 grams. Nitrogen is going to be 1 mole over 14.0 grams. And oxygen is going to be 1 mole over 16.0 grams. So again, all of these masses, I'm getting those from the periodic table. And I can go ahead and do those calculations. 2.85 divided by 1.01 gives me 2.82 moles of hydrogen. 15.82 divided by 14 is 1.13 moles of nitrogen. And then my last one here for oxygen, 54.2 divided by 16 equals 3.39 moles of oxygen. Okay, so now these are going to be my mole-to-mole ratios of carbon to hydrogen to nitrogen to oxygen. So for every 2.26 moles I have, I've got 2.82 moles of hydrogen. And all of this is the number of moles of each atom in 100 grams of my material. So we assumed 100 grams. The reason that we assumed 100 grams was just so that we could get these masses, because these masses represent the percent by mass in 100 grams, right? If it's 27.13% carbon, well, I will have 27.13 grams of carbon per my 100 grams. So these little annotations, right, this is going to be really important for us. We really want to make sure we're doing these sorts of, what do these values represent every time we're doing a problem, because that's going to really help us as we move forward. Okay, so now to go from these number of moles to get to our final empirical formula, the empirical formula is just sort of the simplest way that we can sort of have the ratios of these carbon, hydrogen, nitrogen, oxygen atoms presented. So the sort of way that I go about this is nitrogen is the smallest number of moles. To me, that says nitrogen is going to have the smallest value, right, in our ratio. So I might say that my carbon to hydrogen to nitrogen to oxygen ratio, I'm going to put a 1 for nitrogen. I'm going to say we're going to set 1.13 equal to 1. And then we're going to try to figure out what the ratio of these other things are to nitrogen. So the first one I might do would be carbon to nitrogen. And this is going to be a 1. And then to sort of solve this, I'm going to say 2.26 divided by 1.13. And I'm going to calculate that. That equals 2. So this little calculation here, this is me figuring out what the ratio of carbon atoms or moles is to nitrogen atoms or moles. And again, moles, the ratio of moles is going to be the same as the ratio to atoms. It's just a simpler way for us to talk about it. So 2.26 divided by 1.13, that's a ratio of 2 to 1. So for every 2 carbon atoms I'm going to have 1 nitrogen atom. For oxygen, so now I can do oxygen to nitrogen, that's going to be 3.39 over 1.13. That equals 3. So for every 1 nitrogen, I'm going to have 3 oxygen atoms, and I can put a 3 in over here. So again, this is just representing my ratio of carbon atoms to hydrogen atoms to nitrogen atoms to oxygen atoms. For hydrogen to nitrogen, I'm going to take 2.82, and I'm going to divide that by 1.13, and this is actually going to equal 2.5. So if I actually show you that calculation, 2.82 divided by 1.13, that equals 2.495555. So this to me says 2.50, right? I can round that to 2.50. So this means that the ratio here for hydrogen is going to be a 2.5. Now, if I wanted to write this out, I might write C2H2.5 N1O3. This tells me the ratio. For every 2 carbon atoms, we're going to have 2.5 hydrogen atoms, we're going to have 1 nitrogen atom, we're going to have 3 oxygen atoms. That's what all this sort of information tells us. But we can't have 2.5 hydrogen atoms. That's not, something we can do. It's not allowed. So I need to figure out what I need to multiply this entire thing by in order to get whole numbers for all of these. So I can see that that's going to be a 2. If I multiply 2.5 by 2, I will get to a whole number. So if I multiply all of this by 2, my final answer is going to be C4, H5, N2O6. That's what I'm looking for. All right, let me know if you have any questions.